right, so yesterday was arithmetic sums of series, and today we're going to do geometric. So we're going back and reviewing. Before we do that, real quick, this is posted in Google Classroom, but you had the opportunity at the back of the room or last week to pick up the post-test review packet at some point. That post-test will be given Tuesday and Thursday next week. Okay. And if you're a senior, that will determine 20% of your grade. If you're not a senior, then you have an additional part of the final to take on the final exam day that will, with those two things, determine 20% of your grade. Okay. If you're not a senior, you also have one more summative to take on sequences. If you are a senior, you have the option to take the multiple choice final and or that summative on sequences if you're worried, if you think it would help your grade or you're worried about passing or whatever. Okay? But I need everybody to be very aware that next week, Tuesday and Thursday, are two parts of the final for everybody. Any questions? You have this packet. It looks exactly like the test. So Monday we'll go over the first part, then we'll take the first part, then Tuesday or Wednesday we'll go over the second part and take it. These videos from last year are already posted in Google Classroom. Okay. Yes. Any questions? Okay. On to today's lesson. The learning targets. We're going to talk about geometric. There's an R missing in that word. Geometric means, which means terms that are missing again, but they're being multiplied to find them, not added or subtracted. And then we're going to talk about sum and how to find a sum and applications and summation notation. All right, does anybody remember the two different formulas, explicit and recursive, for geometric from when we talked about them before? Explicit. Okay. Yes. And what did we call? It's not D though, because we're not adding or subtracting. Do you remember what we called it instead of D for difference? It's R for the ratio, okay? Because remember, if you had this, you're multiplying by 3 every time, so the ratio where you put like 6/2 or 18/6 or 54/18, those would all be 3. And you are right, it is to the n-1. And we were kind of careful to put parentheses here because sometimes R could be negative or a fraction or a decimal, and it helped us. And can we ever just multiply A and R? Not if there's some kind of a power up here. All right, recursive, anybody remember what that would look like? You'd have to tell me the first term, and then what? It's in your notes, but it's not going to be on a formula sheet. You take the previous term, and if it's geometric, then you're always doing what? Multiplying by R. That's it. Okay. Any questions? Okay, the next couple slides just to review this again. This is what it looks like on your reference sheet. Please remember that you need parentheses. If you happen to have an older calculator, you also need parentheses around the n-1. But if yours puts it up in a cute little box up there, then you don't. Again, remember, not every sequence is arithmetic or geometric, okay? Very important. And this is what it looks like on your notes sheet. I did put the little parentheses there just to remind you. So let's try example 1. Find the 7th term of this sequence. Again, 3 terms would normally not be enough, but if they told you right here it's geometric, then you do know that it's multiplying by what? -3. So you can pick any term, divide it by the previous term, and you'll get the same. So 72 divided by -24 is -3 as well. So R is -3. How do we get the 7th term? Yep, the first term. 7 minus 1, or 6 times. Okay, don't forget to use your parentheses, because should this be positive or negative? Anybody know? When it's to the 6th power, and negative to the 6th power, it's an even power, so it should turn out positive. So I can show you just to be clear on here. It's 8. You got to have the parentheses if you're going to put the negative in. I'm just going to subtract to my head and put a 6. 5832, yes? Yeah. Everybody good? We did those kind last week, right? Friday, maybe? All right, now it's going to talk about geometric means. Just like arithmetic means were missing terms, okay? Geometric means are missing terms in a geometric sequence. This particular example says there are 2 missing, so I would put 2 blanks, and it actually would mean you needed to multiply by R 3 times, okay, because this is the 4th term. So 4 minus 1 would be a difference of 3 times. Now, you're going to this time divide and then have to take a cubed root. We did a little of this, having to take a cubed root last week as well. And it's not always a cubed root, by the way. Our example that we have says write a sequence with 2 geometric means between 6 and 162. Okay, so 6 was multiplied by R how many times? 3 times to become 162. Because this is the 4th term, so 4 minus 1 would be 3 times. Okay, now what? Yes, do not try to cube root first. You have to use your algebra first. Let's see, that would be 27. And then you can find cubed root button under the math menu. I would highly suggest you just do 27 to the what power? To the 1/3, okay? And you don't need the parentheses if you have the little box up there. The only reason I say to do that is because we're soon going to have to do like a 1/5 or a 1/6 power, and it's a pain in the neck to use that button on the calculator. This is the same as taking the cube root. And most of you could have done that one in your head probably, yes? R is 3. We're not done though. What do we have to do? Yeah, find the actual terms, and remember this should be self-checking. It should come out to 162 at the end. So 6 times 3 is 18, times 3 is 54, times 3 would be 150 plus 12 is 162. Worked? Okay, not taking your calculator away from you, so you can. This is a weird question. It's interesting, it's kind of fun, but I didn't put one of these on the quiz. Can you tell what's happening here? Okay, so if they double this quantity, you'd get this one. If you double this quantity, you'd get this one. So what is the next 3 terms? The common ratio is just yes, the common ratio is 2. Now, someone's going to kill a kitten here. You would have to factor a 2 out of the top to be able to find that common ratio. But we figured it out in our head, right? Okay. But the next 3 they want, so we'd have 8x plus 8 and good job. All right. Interesting. All right, find the first term. Uh-oh. So you could use a little logic or you could use the formula. If we were thinking about the formula, a sub 1 is what's missing, what do we know? So we know the 6th term was actually the first term times r 6 minus 1 times. Okay, we have r and we have a sub 6, right? So 0.1 was the first term times 0.2, 5 times. I'm thinking I'm just going to type that in all at once so that I don't have crazy decimals to write down. So I have 0.1 divided by 0.2 to the 5th. That's what I got as well. Now, if we wanted to figure that out, to check, we could do 312.5, and what was the ratio? 0.2. So here was the first term, second term, third term, fourth, fifth, sixth was 0.1. Is that what we got? Does that check with what's on the paper? Okay. Just showing you how you can check these. Find R. Okay. Want to try this one on your own for a minute? Or are you going to get lost? Right. Ready to get an answer? Me too. Yes, no? Anybody need me to explain better? So I probably wouldn't have even used the formula. I would have just said 15 was multiplied by R and then subtracted these and said 9 times to get to 7680. Then I divided, remember you got to use algebra first, 512. And then I did to the 1/9 because I don't even know. It's under math. There's that 9th root key. And on the newer calculators, it's not as bad as it used to be. Because you can actually put in the 9th root of 512. The older calculators, you had to type the 9 and then go find that thing and then put the number in, and it just didn't make sense to me. It's a little better now. All right, number 4. Does yours still say arithmetic right there? Okay. It should be both. It should be write a geometric sequence that has 3 means, geometric means, between 7 and 567. Sorry about that. That's a bad typo. So basically there's 3 missing terms. between 7 and 567, and it is geometric. So between the first term and the 2, 3, 4, 5th term, right? How many r's were multiplied? 4. So I'm just going to do it the way it makes sense to me. This is all we have to do, right? If it helps you to put the little 1 times 2 times 3 times 4 times up there so that you get that number, right? I don't know what that is. 81, yes? If you divide, and then the 4th root would be 3. So what are the missing terms? 7 times 3 is 21. 63 and 189 times 3 is 567. Did you check? Okay. I always check because easy to know you're getting it right then. We good? I don't think arithmetic mean or geometric mean questions are difficult. It's just remembering, being careful. Are you adding or multiplying? All right. The formula for finding a sum. Remember how yesterday's formula just kind of made sense? Was to add the first and the last and then times the number of terms divided by 2. This one is a little hairier. Okay. I could explain it how it comes about, but it's a little messy. So formula that's on your peep sheet. Okay. This formula, if you don't know the, what is that one for? I forget. If you know the first and last term, but not the term number, then you can use this one. But I did not put this on your reference sheet, okay? You'll have to work out how to find the term number if you don't know it. By the way, anytime you have R, I would put R in parentheses, okay? So this needs a boatload of parentheses, and I have them on the next screen, I think. This is for the sum of an infinite geometric sequence. Let me give you an example of what that means. Now, what makes it a series is if there's pluses in here. And a dot, dot, dot would make it infinite. What is happening every time here? They're dividing by 2. So it's getting smaller and smaller and smaller. If it was a sequence, would it be converging or diverging? It's getting smaller and smaller and smaller. Is it ever going to get negative? No. So it's going to approach 0. Do you remember what that's called? That is converging. Okay. Now, if it is converging, you actually could add this up and it would approach a particular number because eventually you're adding next to nothing. Does that kind of make sense? The rule is you can find the sum of an infinite geometric sequence if the ratio is less than 1. What was our ratio here? 1/2. Yes, 1/2. So this sum would approach 100 over 1 minus 1/2. And if you're typing in your calculator, what's 1 minus 1/2? 1/2. And what is 100 divided by 1/2, please? Yes, good call. Please get that right. So this would approach 200. So we'd have 100 plus 50 is 150, plus 25 is 175, plus 12.5 is 187.5 or something. But what you're adding on is getting tinier and tinier very quickly. Eventually, it's just going to look like if you keep adding that tiny little piece, you're going to get close to 200. That's a limit question almost for calculus, okay? I don't know that I even I don't think I put an infinite geometric series on the quiz. All right, here's my version with some extra parentheses. You may want to write this down. Like I said, if you just always put R in parentheses and make sure the power of n is outside of the parenthesis that has R in. And if you're going to type it all in, you need the top separate from the bottom in separate parentheses. Everybody good? This is the most missed thing on the quiz, is when people have to type this in, they get it wrong. They can write it down and then not type it in right. All right, so let's find the sum of the first 12 terms. First of all, we have to figure out what R is, and it should be dividing any term by the previous term. We should get the same R value. Let's see if that works. 7.5 divided by 6 is 1.25. 9.375 divided by 7.5 is also 1.25. So we can either use 1.25 or 5/4 because they're equivalent. Okay, so the sum of 12 terms equals, how does the formula go? Six. We're going to have a top and a bottom, right? 1 minus, okay, or 5/4, no matter which one you use. And because it's positive, it actually wouldn't matter, but I'm going to put the extra parentheses always. And then the denominator is 1 minus 1.25. And again, the extra set of parentheses here is needed for sure if you have a negative, okay? And it's also needed if you have a fraction. If you actually wouldn't need it for this one, but I'm going to always use it. Okay, 6 times the quantity, 1 minus, I'm even going to do it as a fraction, to the 12th. It's not n minus 1. Did everybody notice that in the formula? It's just to the n, okay? Arrow to the right, close that parenthesis, then divide it by 1 minus 5/4. Okay, now, you could do this in smaller steps, but I'm thinking that's actually an exact number. Does my calculator let me turn this one? Oh, it doesn't. Everybody get this answer? Does anybody know how we could do this in smaller steps to get a fraction? What if I just did the top? The top comes, ooh, that's not nice. All right. What if I just did what if I get rid of the 6? Will that change to a fraction? I don't think it will. It's going to be really crazy decimal. That won't change back either. Is everybody getting the same number, first of all? These same numbers I'm getting? Okay. Yeah. Drawing a blank. Did I try this without the 6? All right. I think we're just going to have to take a decimal for that one. So this one? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm not even sure if that. I think this might be a terminating decimal. Do you see how if I type 1/3, it has more decimal places than this one does? I think it might end there, but anyway, it won't change it back, so we're going to go with it. So I can't. So what did you get?
Yeah.
You should put all the decimal places down, though, on these kind of questions, because the question on the quiz says exact. All right, that was a really bad first example. All right. If possible, find the sum of this geometric series. This is an infinite one, so the only way it's possible to add up forever is if it is converging. Okay, what are they dividing by? Can you tell? 8/40, or they're multiplying by 1/5, right? The ratio is 1/5. But because it's 1/5, we can use this formula. The first term is 40 divided by the quantity 1 minus 1/5. Because it is converging. So I'm thinking times 5 to 50. Is that right? So that is the sum as this would approach infinity. Yes. This formula?
No, this other one.
S sub n is finding the sum. Okay. This is also finding the sum, but it's when it approaching infinity, not the sum of the first 12 terms or the first 6 terms, when it says infinite. This one didn't say infinite, but it had ... Okay. It's only if it's asking you to add up every term ever. And the only way that will even work is if it's a convergent geometric series. I didn't think I put this on the quiz at all. Okay, so find the sum of the first 7 terms. Okay, this means it's finite. Okay, so we're finding the sum of the first 7 terms. What's the ratio, guys? What are they multiplying by every time?
4.
If you take each term and divide it by the previous term, it comes out positive 4, right? So R is 4 and A sub 1 is -1. So we have -1 times 1 minus 4 to the 7th. It's not 7 minus 1 all over. Okay. Now, those extra parentheses inside are definitely extra. You don't need to type them, but I'm just going to be consistent in what I do. But the 7 is on the 4 only. It's not on the whole quantity there. I just hope you're typing these, because if you're not getting this, we need to talk about what you're typing wrong. And I'd rather catch it now than when you have to do a retake. I got -5461. Anyone not getting that? It's just -1 times 1 minus, and like I said, you really don't need an extra parenthesis on this one because it's just a positive number. We good? Yes, absolutely. You have to have a parenthesis around the whole top and the whole bottom when you're dividing. Great question. Now are you getting it? Right, number 6, if the sum of a geometric series, oh, find the sum. Okay, This is one where we don't know the term. This is the last term they want us to add up through, but we don't know the term number. So we're going to have to find the term number first. So the original formula to find any term looks like this. Does this look familiar? What are we going to put in? Equals. We don't know. It's to the n minus 1. But can we do 8 times 1/4, guys? No. Okay. You're going to love this question, I can tell. If we divide by 8, yeah, we get a little tiny decimal. You should be able to do math enter, enter. It's actually 1 over 256 after you divide by 8. If you don't want to write it down as a decimal, it's 0.00390625. It is an exact number. And that was 1/4 to the n minus 1. Where's the variable? How do we find a variable when it's in the exponent? Nolan wins. He's barely awake. He's sleeping like a... We have to do a log, right? He said it. He said it. I was very impressed. Remember, you have to take the log of both sides, but it's not going to be a big deal. When you take the log over here, what happens to the exponent? It moves out in front here. So then what are we going to do? Yes. Are you waiting for me to say this is not on the quiz? It's not on the quiz. 1 log of 1 over 256, close parenthesis, divided by log of 1/4, close parenthesis, is just 4. But that's n minus 1. So what would we have to do? Add 1, which would make it... I love when people get to that last step and then they do it wrong. It's like, we're missing the algebra 1 here, guys. Okay, so let's go back and double check. 8 times 1/4 to the power of 5 minus 1 should give us 0.03125. Did it work? Okay. Are we done? No. They wanted actually the sum. The sum is actually the first term times 1 minus, what is r? 5? N is 5, yes. R is 1/4 to the n, which is 5, all divided by 1 minus 1/4. Okay, please practice typing. I should be doing it in here. But I didn't write it down. What was it? 8? 1 minus 1/4 to the, whoa, forgot to close my parenthesis, to the 5th, close another parenthesis on the outside, divided by 1 minus 1/4, 10.65625, which is a terminating decimal for sure, so it is an exact answer either way. Ugh. So the sum is this number right down here, one of these two answers. Okay. Did you want me to repeat one more time? That question's not on the quiz, okay? If I was going to put that question on the quiz, I would actually give you this other formula, because this other formula here would have allowed us to do that question way faster without using a log. All right. Anyway, it was a good reminder. Can you do this one real quick? Most of you are just going to use the sum thing, right? If I wasn't using the summation symbol, this is A sub 1 and this is R. So I could say I want the sum of 11, where it's 5 times 1 minus 1.06 to the 11th, because it's 11 terms I'm adding, not 10, over 1 minus 1.06. But you can also just use your summation symbol. We make sure we get the same answer. Oh, anybody get 74.858 garbage? And my calculator won't turn it back. Did yours? Huh? I don't know if we put that 1.06 in as a fraction. 1.06, I don't think it'll do it either way, but I don't know. I'll explore that. But put the whole decimal. Don't ever round if it says exact. All right. Find the sum of the first 16 terms. Is this formula explicit or recursive? That's recursive, right? Can you tell me what the sequence would look like? 1, you don't really know what a recursive sequence is, guys? How do you find the next term? What does this say right here? -2 times, what do you say when you see this? Means previous term. So -2 times the term before it. So what's the next number? Times -2 would be 4 times -2. Okay. Now if you had to, could you generate all 16 terms and add them up? I suppose. But the sum of 16 terms, what's the first term, guys? And then it's 1 minus r. What was r? -2 to the 16th over 1 minus -2. Okay. This is what somebody's going to do. There's a question just like this on the quiz, and this is what somebody does every time. They go, okay, well, this would just be positive. That'll save me some time. And this will just be this, so that'll save me some time. One of those things was true, and one of those things was not. Can you do plus positive when this has a power out here?
No.
No. Okay, so just don't do it. Just type it in like that. One minus parenthesis -2 close parenthesis to the 16th, all divided by. Okay, I got -21845. Anybody or not? Okay. I did cheat a little bit. Is this one doing anything? No. I didn't bother with this parenthesis. I just hit enter. And then this really is just 3 in the bottom, right? So I hit enter and then divide it by 3. That was just a way that I could type it faster than you, but I would just use it this way on the quiz and get it right. All right. The sum of each infinite. What does that mean? And it means A special summation. Remember this?
Yeah.
Sum to infinity. It only works if R is what? Do you remember what it said, guys? It only works if R is between the absolute value of R is between, yes, less than 1. If R is less than 1, and it can be negative. Okay. This is not on the quiz. How much time? What's the real time, guys? Okay. I need to get to these word problems, so I'm going to just skip those because they're not on the quiz. I can go back and put it on the video if anybody wants to see it, but these are really just exponential growth questions, guys. It says the car is depreciating by 18%. If you started with 22,000, you would do 1 minus 0.18. And how many years from here to here? 6. You already subtracted, so you just use 6. Somehow people overthink it, and they think they should subtract another 1 because there's a minus 1 in the original formula. Don't. We already subtracted, okay? So it's 22,000 times 0.72 if you want to do it that way. Or you can just do that to the 6th. 66, 88, 15, because we're going to round to the nearest penny. Any questions? All right. From 1990 to 2000, it grew by this percent. So it's 1 plus 0.235, growing fast down there in Florida. Now, they want to know if the original census was this. Yikes. You need a big number here. Okay. How much power, what power are we going to use? Population original to here. 30 years. You already subtracted, so don't take another 1 off. And it's just a ginormous number. Can I skip that one? Okay. A salaried employee is getting an increase by 4.5%. So their salary is going like this. Okay. This was his 10th year. So there was some first term. How many raises did he get by his 10th year, though? 9. And the original salary was, or the new salary after 10 years. Okay, so take this number and divide it by 1.045 to the 9th to figure out what his original salary was. 50,081.41 divided by 1.045 to the 9 raises. So his original salary was about, anybody get that nicely with 0.00 and then a couple little scrabblers behind that? No? Actually, I didn't either when I typed it. 0.41 divided by 1.045 to the 9th. I think you guys must have typed something wrong because I got this. And it says the sum for the first 10 years. Okay, all of the work, guys, is on 7.5a, okay? Bookwork on 7.5a. So for this one, this is R that they keep multiplying by. So then the formula is just, going the wrong way. Sorry, guys. The formula is this guy right here, a sub 1 over 1 minus r, when we're doing finite series, or infinite series, my bad. So it's the first term, if we put in a 1 here, this would be to the 0 power, so the first term is just 13. So it's 13 divided by 1 minus 3/8. 13 divided by, and 20.8 or 104 over 5. This one, the ratio is 1/2, where the first term was 10. So you'd get 20. This one, if you put in, this one is not clearly written in the form. If you put in a 1, you will get out 3 to the 0, which is 1. If you put in a 2, you get out 3 to the first, which is 3. If you put in a 3, you would get out 3 squared, or 9. Okay, I don't know if you remember, but you can only do this formula if r is less than 1, if the ratio you're multiplying by, well, this one has you're multiplying by 3. So this is not a converging series, it is divergent. So you can't find the sum as it approaches infinity because it's just going to keep growing and growing and growing. There is no sum. All right, so the only other question I skipped was this horrible answer. If Florida grew by 23.5% every year, it would be up to let's see, almost 9 billion people by 2030. I don't think there'd be room for it to keep growing by almost 20. Oh, you know what I did wrong, guys? Oh my gosh, I didn't point that out to you. Look, this is a decade. My bad, so this should only be to the third. Okay, totally messed that up. So if they did this in a decade, there's 3 decades in here, so then we'd have 301055252, roughly 30 million people. That's a little more reasonable. So a huge amount of growth, but it took it 10 years to do that. It can't do that every year. All right, my bad. Sorry about that. Here's the bookwork. Sorry the video's so long. Have a good day.